Hello, students. Having studied some of the orbital elements, the constants of motion, and how to get Kepler's laws from Newton's laws, let's see how we can derive more information from the geometry of the orbits. Let's talk about the geometry of bound and unbound orbits. For that, let's first talk about the Semilatus rectum. We established the equation for the radius vector from Kepler's laws, and the same equation also found from Newton's laws. So we can call the numerator of this equation the quantity p. And because it only depends on the angular momentum, this is a constant. Now, if we take this equation, p equal to a I minus z squared, and multiply it by a, if we now expand the right-hand side, we have that a squared is equal to pa plus ae squared. So this is the form of the Pythagoras triangle, where you have the hypotenuse here and the two catheti on the other side. So you have that the hypotenuse is A and the catheti are AE and square root of PA. So we know that AE is the eccentric distance. If you draw the orbit, that's the distance from the center of the orbit to the sun, to one of the focus. So this is the triangle. This is the hypotenuse. That's the semi-major axis. One of the catheti is AE. So the other catheti is the square root of PA, has to be this side. Now, how do we find P itself based on this? Well, because of the property of the ellipse that this side SP over SA is equal to the semi-minor axis over the semi-major axis, and SA is equal to the square root of PA, then we can write that SP is equal to square root of PA times B over A. Well, we also know that the semi-minor axis is equal to A times square root of 1 minus Z squared, which from the definition of P is equal to the square root of PA. So we can substitute the semi-minor axis into the equation and find that SP is equal to P. So the quantity P is the size of the line segment that is perpendicular to the focus S to the ellipse P. So this is called the Semilatus rectum of the ellipse. This is from Latin, semilatus meaning half side, and rectum meaning perpendicular. Again, the main insight from this is that the Semilatus rectum depends only on the angular momentum and is therefore constant.